example 7 was a bit tough because we had to slice it into two different integrals. We had to do one that was perpendicular and one that was perpendicular. Okay, so now we're going to look at a different way. One way that, what if we sliced it parallel to the axis of rotation? All right, think bundt cake. This is the portion where if you want to bring in a bundt cake, I will be more than happy to help you eat it. All right, so we're kind of making this like cylindrical shell shape. We're cutting it parallel and spinning it around. All right, so this thing's called a cylindrical shell. Got that? All right, and I like this analogy here. We're taking a really thin shell. So we're thinking school bought toilet paper, okay? Or the terrible tissues that I can't stand. That's how thin we're talking. So if we want to do the shell method, we're going to rotate a region that parashell to the axis of rotation. Parallel, pair of shell, get it? All right, if that's coming. And it's pair, like pair. All right, a pair of shells. So that's why it's 2 pi instead of pi this time. So 2 pi times, we have the radius times the height. All right, we won't have to worry about any holes because we're making a shell here. All right, so we're going to do the one from example 7 again, but this time we're going to set it up a little bit differently. All right, so we have y equals x squared plus 1 here, y equals 0, x equals, let's put x equals 1 there. All right, so what we're doing now is we're going to make these infinite little shells. Let me make this thinner. All right, so we're going to have like a little, like down here will be a little kind of shell, okay, and then we'll put another one around it and another one around that, okay, and we're kind of building this like a big old roll of toilet paper. All right, so the hard part, it might be hard to think of at first, but it's not too tough. The radius of these shells is going to be like here for that one, here for that one. The radius is actually going to be just the x value of where we are. Okay, and actually, in fact, anytime you're revolving around the y-axis, the radius will always be x. Now the height, in this case, it's always good to draw it. The height is just from that line, our y equals x squared plus 1 minus 0, top minus bottom. And in this case, we also have dx. Okay, so x squared plus 1 minus 0, so top minus bottom. So our volume, we are parashell to the axis we're rotating around. So pair 2 pi integral from 0 to 1 r of x times h of x dx. So our r of x is 1 dimension, h of x is 1, and the d of x is 1. That's what makes it a 3D shape. So 2 pi times the integral from 0 to 1, our r of x, x, h of x, x squared plus 1 dx. I'm going to distribute before I multiply, before I integrate. So x cubed plus x dx. Add 1 to the power, divide by the new power. Don't forget to bring down your constants. And we're integrating from 0 to 1. So we have 2 pi times 1/4 plus 1/2 minus 0 for both of those. All right, 1/4, that would be 3/4 times 2 pi. Okay, or another way of writing it would be 3/2 pi for our volume, which is the same thing that we got before. Now it was just a little bit easier method. So buzzword of the day, parashell. All right, now let's find the volume of that bundt cake that Susan is going to bake for us. All right, the region enclosed by the x-axis, and sorry if I use this video for any other year, but 2014, #1 class ever. Okay, so now we have a different graph. Here we're going to have this graph, and if you need to, you should know where this equals 0, but you could set it equal to 0. You'll find that it's 3 and 0. And we're going to rotate it about the line x equals -1 over here. So we're going to if I have my dx here, that's parallel to that axis, so we're going to use the Parashell method. My radius, okay, my radius is going to be from here to here. So it's going to be my x value, whatever one I pick, minus -1. X minus -1, or x plus 1. My height is going to be the function minus 0. So now let's set up our integral. Volume equals, since we're doing the Parashell method, we have 2 pi. We're going from 0 to 3. My radius is x plus 1. The height, 3x minus x squared, dx. We have our 3 dimensions, 1, 2, 3. Now I would multiply this out before integrating. So what do we get? 3x squared minus x cubed plus 3x minus x squared dx. Okay, simplifying that. I have 3x squared minus x squared, so I have 2x squared minus x cubed plus 3x. You can put it in any order you want, doesn't really matter. Once you integrate, add 1 to the power, divide by the new power. 2/3 x cubed minus 1/4 x to the 4th plus 3/2 x squared, evaluated from 0 to 3. Alright, I think I got it all right. 2 pi. Plug in numbers. Actually, for this point, does it say calculator? I'm going to make this a calculator one once you get your setup. When you solve this, just for the sake of time, and you could do it. Nah, I don't want to. 54/3. Okay, plug it in, ... whatever. You end up with 45 pi over 4, or about 70.685. If you do this and can't simplify it, let me know, I'll help you out. Alright, example 9. Find the volume of this. Ooh, exciting one. Use both vertical and horizontal slices. Alright, x squared looks like this. Square root of x, something like that. Alright, use both vertical and horizontal. So, we're going to rotate it about the y-axis. I guess I'll do the vertical ones, which would be the Parashell method. Okay, vertically. So this would be my dx. Okay, my Parashell method. Alright, so volume equals 2 pi times the integral of, well, I know I'm going 0 to 1. My radius, though, what is my radius here? It's just going to be x. Okay, because that's how big I want it. Okay, my height is going to be square root of x minus x squared. So I have x times square root of x minus x squared dx. 2 pi times the integral 0 to 1. That would be x plus 1/2, x to the 1 plus x to the 1/2, x to the 3/2, minus x cubed. 2 pi times, add 1 to the power, divide by that new power. Evaluated from 0 to 1. 2 pi times, looks like 2/5 minus 1/4, which gives us, that's 3/20. Alright, so we get 3 pi over 10. Alright, so for the, better pick a different color this time. Let's see, horizontal method. Let's go with blue, why not? Horizontal method. So this time, if we're cutting it horizontally, can I pull this out of there? There, good, okay. If I'm trying to pull this horizontally, it's this way. Okay, now it's not Parashell anymore. And there is going to be a hole, so this will be our perpendicular method. Alright, so we're going to have to find our big radius, our little radius. So my big radius is going to be x squared. Oh no, it's not x squared, is it? Oh, I don't know what I just did. Okay, go back to that page. Wrong page. I'm so close to the end and I'm falling apart. Alright, I think we're on this page. Great. Okay, it's not x, because now I'm doing it in terms of y. That's what I should have picked up right away. Alright, so this is dy. So my r of y, my big radius, isn't going to be x squared. Instead, it's going to be the square root of y. Square root of y minus 0. My little, this will be y squared equals x. Okay, my little radius is going to be y squared. So now I'm going to set up my volume, pi times the integral. From 0 to 1, the y values happen to be the same as the x values. Square root of y squared, big R squared, minus little r squared, dy. Volume equals pi integral 0 to 1, y minus y to the 4th dy. Use the power rule here. Zero to 1, great. We're still going. 1/2 minus 1/5 minus 0 minus 0. Good. Okay, pi times 3/10. And look, we get the same exact answer as we got before. Now, which method was a little bit easier? Maybe the numbers over here in red on the perp and Washula method were easier. Maybe not. Still doable either way. So we'll be able to look and decide which method you prefer. Now we have one more set of notes that we're going to start. Our last video of real notes will be the next one. Pretty sad, pretty humbling. You've made it through, all right? And we'll be talking about volume a little bit differently. Okay.